Hello friends, welcome to the class of High Voltage Engineering. So in today's lecture, I am going to discuss about the breakdown voltage test on the transformer oil. So generally, the breakdown voltage test is a very basic test to identify the breakdown voltage capacity of liquid dielectrics. So that test is generally performed by following the test procedure suggested by either IEC 156 or IS 6792. So let us discuss that how this breakdown voltage test is conducted on liquid dielectric. So in this lecture, our point of discussion is towards the transformer oil specifically. So generally in the industries, you may come across with not the breakdown voltage test like a longer name. Okay, but when you work in the industry, you may come across with the sentence BDV when the two engineers are talking with respect to the breakdown voltage capacity of any liquid dielectrics before its application in the high voltage equipments. So generally they are used to ask or used to say a BDV value. Okay, so here the BDV stands for the breakdown voltage. So what could be the definition, how we can define this breakdown voltage? Okay, so we all know that the breakdown of a liquid dielectric or any given insulation takes place at maximum voltage. So that breakdown voltage can be defined as a maximum voltage at which the one can observe the formation of the spark. Okay, so in other way I can say it as a spark over voltage if I am considering the insulator surface where the flashover is arising. Okay, it is also obviously say to be a one sort of breakdown voltage, but in that case the breakdown is appearing over its surface. Okay, so in case of the solid dielectrics where we are observing the spark formation over the surface, let me draw the picture to clear it more. Suppose this is the insulators. Okay, suppose this is the insulator which I am representing over here, and if suppose one is observing the spark over its surface, then this is known as a flashover. Okay, this is about the solid, but if we are considering the liquid dielectric where the two electrodes are there, let us assume that this is the circuit breaker contact, and in between them suppose the liquid dielectric, or you can assume the gas as an insulation. Okay, so in that case is during its opening operation under the faulty condition, the voltage across these two contacts at a certain distance will be higher than its withstanding capacity. As a result, it will produce the spark. Okay, so this is also known as a flashover. So sometimes instead of using this BDV, the engineers may say the flashover voltage. Okay, so why we are using this? Okay, so in case of the liquid or the gaseous dielectric, you can use the word either the flashover, but in case of the solid, the flashover will be applicable only to those spark which is observed over the surface into the air. Okay, so ultimately the process that we are observing is the breakdown of the gap between the two electrodes, and that is known as a breakdown of an insulation. Okay, so breakdown of a given insulation always appeared at a maximum voltage. Okay, so the maximum voltage at which the breakdown takes place in a given dielectric is known as a breakdown voltage. Okay, now as we are dealing with this high voltages, so the unit that we are considering for this is in terms of kilovolt. So sometimes it is also called as a dielectric strength value. Okay, So when you are representing this BDV in terms of its dielectric strength, then you can also call it as the maximum value up to which the unit thickness or unit volume of a given dielectric can sustain, okay, can withstand the applied voltage. Okay, so there might be a little sort of the confusion that you can observe between the dielectric strength and the breakdown voltage. At one part, the breakdown voltage exactly defines what? It defines the voltage at which the breakdown will takes place. And what exactly this dielectric strength is defining? The uh, capacity of the insulation to withstand the maximum stress. Okay, so if suppose, so now how we can differentiate these two? If suppose while you are reading the report, and suppose you are reading, let me take a simple example of this air insulation under the standard atmospherical condition. Okay, suppose 1 centimeter of gap is there. Now you know the dielectric strength of the air at standard atmospherical condition is 30 kilovolt per centimeter. Okay, so if we are keeping the distance of separation as 1 centimeter, then that capacitor will need 30 kilovolt to break the gap of 1 centimeter. Okay, so if one is want to the value define the value in terms of its dielectric strength, then it must be written in terms of this kilovolt per centimeter, kilovolt per millimeter, kilovolt per meter, likewise. Okay, but if suppose one want to reflect the value in terms of its breakdown voltage, then it must be represented in terms of kilovolts only. Okay, so if we are considering this, then there is no difference between the breakdown voltage and the dielectric strength. Only the thing is representation. Okay, so the BDV value, obviously it defines the dielectric strength of the given dielectric material. Okay, so it may indicates the presence of contaminants, because if you are considering the impurities, obviously you will observe the breakdown voltage magnitude lower than the expected one. So if the value of BDV is supposed to be higher than it indicates, then the presence of contaminants is lower. Okay, so one can identify the purity of liquid dielectric just by performing this breakdown voltage studies. So minimum value of the breakdown voltage lies in the range of 30 kV to 40 kV. So it depends upon the moisture that could be present in the transformer oil. So if the moisture is higher, then the breakdown voltage will be lower in transformer oil. So if suppose I am plotting the characteristic between the breakdown voltage, or let us say the voltage versus moisture content, which is obviously measured in terms of ppm. So if I am gradually increasing the water content, then the breakdown voltage goes down. Okay, so generally when you are dealing with the liquid dielectrics, the moisture content plays a very important role, because if suppose I am adding let us say the 1% of water particles, 1% of water into the transformer oil, then it will reduce its dielectric strength by an amount of approximately 20%. Okay, so the water content or the moisture plays the very important or the crucial role in the performance of the transformer oil when it is subjected to the electrical stresses. So breakdown voltage test is a very important test for the transformer oil. So during the time of transformer operation, the oil become degraded, which may be the main cause for the loss of function, decreasing the cooling capacity of transformers likewise. Okay, so BDV test is used to test or check the quality of transformer oil in the form of by measuring its breakdown voltage capacity. So depending upon the result of BDV test, the oil will be refined or purified again. Okay, so if suppose after the purification the breakdown voltage is not achieved as per the expected value, then you have to replace that transformer oil. Okay, so this test will be repeated every in 6 months. Okay, so for that you have to take out the sample of the oil from the drain side, drain area of the transformer by using from the drain side, the drain valve normally provided at the bottom of the transformer tank. So you just open that tap, take out the sample, and then conduct the breakdown voltage test. So if suppose the value is within the permissible range, then it does not need any kind of the purification. But if suppose the value gets violated, then it needs the purification. Okay, so in general there are the two methodologies by which you can purify the transformer oil. Either you can approach with the offline purification system, or else you go with the online purification system. Okay, so in case of the offline, you have to disconnect the transformer from the service, then the oil will be circulated through the purification system, and at the end it will be tested for its BDV value. Whereas in case of the online purification system, it does not require the disconnection of the transformer from the service line, and the oil is circulated through this purification system. Afterwards it will be tested for BDV test. Okay, and then it will be redirected to the reservoir, which is a tank of the transformer. But generally the offline purification system is more adopted, because you are testing the BDV value of the transformer oil after 6 months of duration. Okay, so if you suppose find the values lower than the expected one, then it needs the replacement, because even after the purification you have not achieved the required value. Okay, so in that cases it needs a replacement of the transformer oil. Okay, so in general, first you have to perform the BDV test by taking the sample from the transformer. If it is supposed to be lower than the expected, then it will be circulated through the purifier system. After the purification, again the sample has been taken out from the transformer tank and retested for the BDV test. So after the purification, if you have achieved the value within this prescribed value or prescribed limit as suggested by the IEC or the IS standards, then you can go with that. But if suppose after the purification still you have not achieved the required value, then it indicates that your oil is completely contaminated. Okay, it has loosened its all insulating properties and the heat transfer capabilities, so it needs a replacement. Otherwise it may turn the transformer action into catastrophic failure. So let us see that how this breakdown voltage test is to be performed on the transformer oil, or even on any liquid dielectrics. So this is a basic circuit diagram of conducting the dielectric strength or the breakdown voltage test over the liquid insulation. So here you can observe that the input is simply of 230 volt AC that we are getting directly from the distributors. Okay, electricity distributors like electricity board. Okay, then variac is used to just vary the voltage level, okay, to a specified value. Of course, now it needs a higher voltage magnitude, so what it requires the high voltage transformer, which is a single phase step up transformer, which converts this low voltage into the higher voltage value. And at the end you can see the test cell in which the transformer oil is added. Okay, so it consists of the two electrodes which are completely immersed. They are completely immersed by this transformer oil. So as per the IEC or the Indian standards, the length of gap which one has to set between the two hemispherical electrodes is either of 2.5 millimeter or the 4 millimeter. It depends upon the client. Okay, so this is the basic circuit diagram. If suppose during the testing if you find that there might be a problem occurring to the high voltage transformer side, then you have to isolate the source from the tested objects. Okay, so to prevent the unnecessary damages to this high voltage transformer under the faulty situation, the circuit breaker is obviously provided during the faulty situation. So now here, where exactly the fault has been created? When you observe the spark across these two electrodes. Okay, so when the short circuit is arising, a huge amount of current is flowing, so we need to disconnect source from the high voltage devices just to prevent any damaging effects. So this is the simple circuit arrangement for conducting either a breakdown voltage test or the dielectric strength test on any liquid dielectric. Okay, so here you can see how exactly the test cell looks like. Okay, here you can see these are the two hemispherical electrodes, and the length of gap between these two spheres is adjusted as 2.5 millimeter. So here there is a question that how we can adjust the gap of 2.5 millimeter, because it is very hard to measure 2.5 millimeter by using the scale mechanism. Okay, so when you are purchasing the breakdown voltage test kit for liquid dielectrics, the manufacturer will provide you one standard gauge. So here you can see this is the standard gauge. Now on the standard gauge, if you can see, the two sides are there which are flattened. Okay, so on these two slides you will found go at one side, and at other side you will found no go. Okay, so if suppose I have the gauge of 2.5 millimeter, then go indicates its diameter as 2.5 millimeter and no go indicates 2.6 mm. Okay, so no go, it means that it has a diameter more than the go area. Okay, so when you are adjusting, see here both the electrodes are movable. Okay, so by using the spanners you can adjust the gap between the two electrodes. So here you have to adjust 2.5 millimeter or 4 millimeter gap between the tip to tip position. Okay, because this is the area of the spark. So between tip to tip position you have to adjust the gap. So how you can adjust the gap? You have to fix one of the electrode, and then you have to place a go area in touch with the tip position of the electrode, then vary the other electrode and adjust the length of gap. Okay, so when you are changing when you are moving this electrode, you have to move until the tip position of your movable electrode will touch to the surface of go side. Okay, so after that you have to fix both, then you have to pass no go area. Okay, it should not be passed through the gap. Okay, but when you are passing this go, it will be easily passed from the length of gap. So this is how you can adjust the length of gap between the two electrodes during the conduction of this BDV test on liquid dielectrics using BDV oil test kit. So let us see how it looks like. So this is the real photograph of BDV test kit. Okay, so as you can see, if you are considering the entire test setup, then it includes vessel of glass, plastic or transparent with 300 to 400 milliliter of transformer oil or any liquid dielectric for testing purpose. Okay, so this test cell will allow you to fill up the liquid up to 300 to 400 ml, and the temperature of the oil should be 27 degrees Celsius at the testing time. Okay, so we are normally considering the room environment. Okay, the two electrodes may be of copper, brass, bronze or stainless steel electrode of 12.5 millimeter to 13 millimeter in size, and dipped these electrodes into the vessel. So electrodes must be polished before pouring the oil into the test vessel. Okay, so electrodes must be polished in a spherical shape, as you can see over here, and the distance between the two electrodes should be 2.5 millimeter. Okay, so this can be achieved by this standard gauge. Before the testing, the vessel may be disturbed due to the homogeneous distribution of impurities and air bubbles to escape. Okay, it is a simple phenomena that when you are pouring the transformer oil, when you are pouring the liquid into the test vessel, you always found the production of the bubbles. There might be the mechanical vibrations, so you have to wait until all this can be settled. Okay, so as you know that the bubbles are very light in terms of weight compared to the liquid, so you have to wait until the bubbles can be removed from the sparking region. Okay, so they will be traveling from bottom to the top side, so you have to wait at least for 1 minute until the vibrations of the oil gets died out and the bubbles or the bubbles are settled over the top, the solid impurities are settled to the bottom side. Okay, otherwise after pouring the liquid and in the presence of the solid impurities and the air bubbles and the vibrations, and you have given the voltage, then it may create the instant breakdown, which is not the expected one. Okay, so after 1 minute of time, apply the alternating current voltage to the electrodes frequently from 0 to the voltage value until you observe the formation of the spark. So the transformer is generally, here you can see that the rate of rise of voltage that you can observe in this circuit is 2 kilovolt per second. So when you are placing this toggle switch onto the raised position, the voltage is increased until the breakdown is initiated. Okay, so that rate of rise of voltage is 2 kilovolt per second. At the breakdown, the circuit breaker will trip and the breakdown voltage should be noted. So generally when you are performing the breakdown voltage test on a liquid dielectric material, first magnitude one has to avoid, because the first spark is created to produce a perfect dry condition between these two spheres. Okay, because the transformer oil is hygroscopic in nature. Okay, so when you are pouring the liquid, it has tendency to absorb the moisture. Okay, so first we need to remove that moisture. So to remove that moisture, first we have to create that heating effect by means of the spark production. Okay, so the first voltage we have to avoid, and that voltage is known as a first discharge inception voltage, to eliminate any moisture content present in the area of the spark. Okay, so the first value is normally avoided. Afterwards, if you can see at the bottom of the two electrodes, one stirrer is provided. Okay, so after the initiation of the breakdown, you have to keep on this stirrer just to remove the bubbles and the other carbon particles. okay, because you know that in case of the liquid dielectrics, when the breakdown takes place, the liquid may get carbonized. Okay, so this this carbon impurities we need to remove from the region of the spark to obtain the actual value of measurement. So to remove it, we need to stir it. The second is, at the event of the breakdown, the hydrostatic pressure of the oil gets changed. As a result, it may introduces the bubbles. So again we need to remove those bubbles. Okay, so what it needs some kind of the external force, and that external force can be provided by this stirrer. So after the first breakdown, the stirring process will be done for at least for 1 minute, so that we can remove the contaminants from the surface of the spark. Afterwards, we have to switch off that stirrer, and again we need to wait for the 1 minute until the liquid gets settled. Okay, so normally the test is repeated at least 5 to 6 times. So the test engineer have the 5 readings. Let us say for suppose I'm conducting the test for 5 times. Okay, so I have the 5 readings. Now I need to take the average of those 5 readings, which gives me the breakdown voltage value or the dielectric strength value of a given dielectric material. So based on that value, I can judge the quality of insulation. So these breakdown tests are taken after every 5 minutes, and each time the breakdown voltage should be recorded. So average of all the readings will give the dielectric strength or the breakdown voltage of transformer. So here you can see the permissible limits are suggested. If suppose the equipment's rated voltage is less than 70 kilovolt, then BDV value should be greater than 30 kilovolt. So here whatever the values that you are seeing is 30 kV per 2.5 millimeter of gap. Okay, because in actual condition, if one is assume the dielectric strength of transformer oil, then it is approximately around 150 kilovolt per centimeter. So if you want to get the same value, it needs a larger size of equipments. Okay, so in order to achieve the compactness towards the equipments used to test the dielectric strength of liquid insulation, the length of gap should be reduced. So once you are reducing length of gap, it requires lower voltage magnitude, it needs a lower size of transformers and everything. Okay, so you can see that very small or the compact device is used to measure the dielectric strength of liquid insulation. After achieving the average value, it will be transformed into the per centimeter value. Okay, so whatever the result that you are seeing over here is for 2.5 mm gap. So you need to convert it into the per centimeter value to achieve the actual one. Okay, so if your equipment is rated for a voltage value somewhat lower than the 70 kilovolt, then the expected result for the breakdown voltage is 30 kV. Okay, for 70 to 170 kilovolt, it is greater than 40 kilovolt, and if suppose the rated voltage is greater than 170 kV, then the value which is required is greater than 50 kV. Okay, so this is how the breakdown voltage test is performed into the testing laboratories. Okay, so this breakdown voltage test is a very basic test which is performed onto the liquid dielectrics just to observe its quality in terms of its electrical performance. So let us see that how this breakdown voltage test is conducted on the transformer oil. Sorry.
नमस्कार दोस्तों, आज मैं इस वीडियो में बताने जा रहा हूँ पावर ट्रांसफार्मर के ऑयल का BDV.
Okay, I will share this video link in the description of this lecture so that you can study very deeply by assessing the other videos as well.
टेस्ट के बारे में, पावर ट्रांसफार्मर का बीडीवी टेस्ट यानी कि ऑयल का ब्रेकडाउन वोल्टेज टेस्ट। ब्रेकडाउन वोल्टेज टेस्ट हमें ऑयल की डाइलेक्ट्रिक स्ट्रेंथ के बारे में बताता है।
So here you can see the testing engineer has picked a test cell in which you find the two electrodes which are made up of stainless steel. Okay, instead of using this stainless steel, you can also use the bronze material or the copper material, or even you can select the copper bronze. It depends upon the requirement.
डाइलेक्ट्रिक स्ट्रेंथ जो होती है वो ऑयल की प्राइमरी हेल्थ के बारे में बताती है। ऑयल की प्राइमरी हेल्थ यानी ऑयल में मौजूद मॉइस्चर कंटेंट, कंडक्टिव सब्सटेंसेज यदि प्रेजेंट है तो उनकी प्रेजेंस के बारे में बीडीवी टेस्ट से पता करते हैं। इसका टेस्टिंग किस तरह से करते हैं आप ये देख रहे हैं। ये एक पोर्ट है, पोर्ट के अंदर ये दो इलेक्ट्रोड हैं। इलेक्ट्रोड के बीच में हम 2.5 mm का गैप मेंटेन करते हैं। इसके लिए एक गेज दिया हुआ है। गेज में दो तरह से मार्किंग होती है, एक पे लिखा होता है गो और एक पे लिखा होता है नो। गो में 2.5 mm गेज का जो गेज होता है वो गो कहलाता है। उसको हम दोनों इलेक्ट्रोड के बीच में डाल के चेक करेंगे, दोनों इलेक्ट्रोड के बीच का गैप। ये आसानी से अंदर जा रहा है। फिर इसमें इस गैप से ज़्यादा वैल्यू तो नहीं है, इसके लिए हम नो वाला जो साइड है गेज का वो डाल के देखेंगे। हम देख रहे हैं कि ये 2.6 वाला अंदर नहीं जा रहा, मतलब इससे ये 2.5 mm दोनों इलेक्ट्रोड का हमने गैप मेंटेन कर लिया है। अब इसके बाद हम इसमें जिस भी ऑयल का टेस्टिंग करना है वो ऑयल को जब तक ये इलेक्ट्रोड दोनों डूब नहीं जाए उतना इसको भर के रखते हैं। दोनों इलेक्ट्रोड को ऑयल में, जिस ऑयल का बीडीवी टेस्ट करना है उसके अंदर डुबो दिया गया है। अब इस ऑयल पोर्ट को हम बीडीवी टेस्टिंग किट में रखने जा रहे हैं। वीडियो टेस्टिंग किट में इसको रखे के बाद 5 मिनट बाद फर्स्ट सैंपल लिए। थोड़ा सेटल भी हो जाएगा ना काम। वीडियो टेस्ट किट का रेट ऑफ राइज वोल्टेज 2 किलोवाट पर सेकंड होता है। जो आपने देखा 90 इस वोल्टेज पे 90 किलोवाट पे दोनों इलेक्ट्रोड के बीच में स्पार्क हुआ और इसका वीडियो टेस्ट रीडिंग आई 90 किलोवाट। इसी तरह एक सैंपल के हम 5 से 6 बार टेस्ट करते हैं। उनकी एवरेज रीडिंग जो होती है उस वैल्यू को हम वीडीवी टेस्ट वैल्यू फाइनल मानते हैं।
Okay, so you have seen in this video that how exactly the breakdown voltage test is conducted on the transformer oil. Okay, so this is how the average values has been taken. Average value is being taken from the consecutive readings to enable the quality of the transformer oil. So This is about this breakdown voltage test of transformer oil. Thank you.